Now we're going live. All
Okay.
right, now we're live. Okay, sorry. Apparently, I have to press the button that says "Go Live" for this to start. All right, welcome to the Geology Flannelcast, everybody. All right.
That makes a lot of sense.
Yes.
You would
Good
think,
evening, everybody. Good evening. I am Steve.
I'm Chris.
I'm Jesse.
Welcome
right.
to the Geology Flannelcast live.
Yeah, I brought all the energy to my introduction there.
Yeah.
For everyone watching right now, we totally thought we went live for about a good solid 30 seconds, and we realized we weren't going live. So sorry about that.
Yeah.
Well, I guess
We wasted the
I'm
good
sorry, you didn't hear it.
surprise on you. As a Big Daddy reference. I think that was a 2000.
Oh, that's right.
Yeah.
That might have been 99.
We'll have to look it up.
I do like how this is slowly morphing into just a movie podcast.
Just movie quotes, yeah, because that's my whole life is pop culture.
Yeah.
Man. Well, we got an action-packed episode today, so no guests this week. We're just gonna, kind of just keep on rambling on about news stories. But there's some cool stuff in the news going on this week, and actually every week in the world of geology. So
Every day, even.
every day, it's like the Earth is always changing every single day, so something's always happening. It's just-
Keeps on moving.
Now, let me ask you guys a question. Do you guys get the USGS alerts for the earthquakes?
I don't. Do you?
Jesse?
No, I do not.
So I have it set up. You can actually set it up on the USGS website for a certain magnitude earthquake to send you alerts. Lights go off in my house, alarm buzzers, cans start rattling.
Your Alexa just shouts like, "Get under a table!"
Yes.
No matter where it's at.
And I get all I set it at like 5.5. When I first did it, I was like 5.5. That's a pretty big earthquake. Yeah, that they happen all the time. Apparently, that got annoying. so
it would just go off whenever there's a 5.5 anywhere on Earth.
Anywhere on Earth, yes.
Oh yeah, that would get really annoying.
Yeah. So I moved it up to like 6, and surprisingly, that's probably once a week to maybe, I would say on average, 50 times a year.
Huh.
So,
about once a week.
But every time I get one, I'm like, I get all excited and / worried. Like it's such a roller coaster of emotions every time I get an alert. And 9 times out of 10, it's like Vanuatu, like somewhere in the middle of the Pacific Ocean where nothing happens anywhere. Like it's like 75 miles northeast of Guam. I'm like, okay, well,
I'm sure the good folks on Vanuatu.
Yeah, Vanuatu. Sorry, thank you.
Are not saying nothing ever happens.
No, true. But
hit by a 6.0 earthquake.
But I was just curious to see if anybody else had that.
No, I do. I follow them on Twitter, and so they're always tweeting out sort of big ones. I do check in the web. I love the website where you can play with the filter and you can see it shows you where they're at. It's a great little website they put together there.
So anyway, there was a big earthquake today, but
Wait,
quick, 6.2, I think.
Oh. On Vanuatu?
I think that was the closest spot. I'll have to look it up, but
I might be Oh man!
Wait, where's? Sorry, I was putting up on Facebook and Twitter that we were on
this
live
was
right
in
now. Where's Vanuatu now?
So
actually, there was a 6.6 in the Java Sea. That's where it was.
And we should. I think you were right with whatever Vanuatu. I think is actually the fake island on
a fake island.
No, Vanuatu is a real place. In a sea change.
If there's any Vanuatuese listening to this right now, please comment.
So in sea change, with a class that we teach up at Rutgers, we sometimes use Michael Crichton's book, where his climate change skeptic book, and he has a fake island that's supposed to be Vanuatu, but he names it something very similar, and I always get them confused in my head. That's my story.
Yeah.
It's a great story there.
Thanks.
Jesse.
All right. Well, see you tomorrow.
Hey, so while we're live, are we gonna pay some bills here?
Oh shoot.
Yeah, let's go. We should do that. Yeah, good call.
Yeah.
I always, yeah. I get all flustered when we do these live things right now.
Yeah,
so.
I know.
You gotta get used to
you'd
these,
think
you know?
we would set up some organized Word document with like bullet points
Did you do that?
to organize us for our kickoffs.
Have you done that? I feel like you've done that.
I should, but I feel like if I needed to, we could go to the formattingformula.com and they would show us videos about how to do such.
Son of a, I missed that whole setup right there.
It's 2 weeks in a row.
Yeah.
He missed it 2 weeks in a row.
Not the sharpest.
Yeah.
All right,
but-
go ahead, Steve.
No, but seriously, if you ever have any Word formatting documents, anything you have to format in Word, whether it's as simple as like page numbering, headers, footers, embedding figures, whatever it is, Mac, PC, I'm a PC person. Mac, I've had to use Macs in the past. They're all slightly different. But the formatting formula knows those slight differences, and they actually have YouTube videos at youtube.com/c/formatting formula. Hundreds of hours of videos like explaining anything from like something super simple to like super intricate. They can talk about custom headers and things like that if you do something all the time, like just crazy stuff that I didn't even know you could do. So, and they've been a great supporter of the podcast, and we really want to support them. So please check them out, youtube.com/c/formatting formula. You won't regret it.
They've been with us from early on, and we owe them a lot.
Right. They have. They
folks.
see our potential.
Yeah, the good folks over at the Formatting Formula. Please check them out.
Tell them we sent you.
Oh, yes. Also do that.
Yeah. Because then it makes us look like a boss. Like,
an
my investment's actually paying off.
Yeah, it's an important part of the transaction.
Yes. Instead of just wasting money on 3 schmoes. So,
Coincidentally, Three Schmoes is the spinoff podcast we will be starting
yes,
immediately after this one.
Yeah, it's all about catching Sasquatch.
Oh man, that sounds all. I'm in.
I'm down.
You don't have to tell me anything else.
I'm down for that. That would be amazing. All right. Sorry. Should we dive into this?
Let's just if you also want to help out besides going to Formatting Formula, you could always support us by going to our Patreon. We would appreciate any support. If you've got any to offer, we've got different tiers. So you can check that out, patreon.com/Geology Flannelcast.
Yeah, we actually picked up two Patreons today, or one? Two.
Yesterday, too. Yeah.
Yesterday. Yeah.
Yes.
So
Shout out to them.
yes. Thank you very much. We really appreciate it.
There was other people I had to give a shout out to, but I forget now. I'll catch them next time. That's a good thing about doing this. Until we go on another 4-year hiatus.
And as we see the live viewers drop off one by one, because Jesse forgot to mention their name.
They were only here.
Yeah. Yeah, that's funny. We did get a shout out from Sheila saying it's funny. She posted, Sheila was the secretary in our department at Temple University years and years ago. She still is now, but she posted, I didn't know my baby Chris was doing the Flannelcast. And I instantly thought it was you, Semenak, but she was talking about Chris Conwell.
Yeah.
I know. And I was like, Sheila, what about me and Jesse? And she's like, I love you too, Stephen. And I was like, oh, wait.
Not as much.
I was like, she was talking about Conwell. She wasn't even talking about us at all. She doesn't care about it.
Did not care.
No. So, yeah.
That's
so, Sheila's not listening. Great. But she's great, but she's not listening.
all right. So let's I got some interesting news stories to start off with here. So let's Let's start off with I got one that's pretty neat that came out this last week. So, guys, when I talk about earthquakes to you guys, what would you think is like the holy grail of earthquake science? Like, what is the one thing that every geologist, God, the look of panic on both their faces right now.
I'm like, I know you want a specific answer. But,
predictability, right?
oh yeah, never gonna happen.
Yes.
Don't try and tell me it's gonna happen. Is it gonna happen?
Well, now there is some earthquakes or some fault lines that have, from my understanding, there's one in Turkey. It's either Turkey or Iran. I want to say it's Turkey, but I don't know off the top of my head. But the earthquakes are predictable in the sense they know it's been moving along this fault line.
Oh,
right?
yeah.
That's not what we're talking about today. But I'm just.
Oh,
Is that
yeah, Anatolian?
Or the east or the north, one of the Anatolians.
Okay.
Just call it the
So that
Anatolian.
one, sure.
Just want to keep interrupting you.
I don't know what the name of it is. I just know there is one out there.
It's
like
the northern
kind of
Anatolian
the Middle East. Okay. So that's predictable in the sense that the earthquakes are moving along the fault. They're moving up the fault. It's like one of the only ones in the world that does this, but they can't predict like when it's going to happen. They just have a general idea of where it's going to happen. Well, there is a story out, and in the along the Cascadia Fault, which is off of the that's off of like the Pacific Northwest in the Pacific Ocean, just west of the west coast of North America. They have a slow earthquake there. All right. They have not slow earthquake singular. They have slow earthquakes, and they're looking at these slow moving earthquakes. And a new study comes out, and the geologist looking at this.
Real quick,
yes,
what is a slow earthquake?
Well, I can get to that in.
Sorry. All right.
So it's.
Well,
it's essentially okay. I have it right here. It's an event where the tectonic plates grind incredibly slow against each other, like an earthquake in slow motion.
Yeah,
but the interesting thing with these things is a slow slip event that occurs over the course of weeks might release the same amount of energy as a 1 minute long magnitude 7.0 earthquake.
Now, that just, sorry, I'm going to interrupt you again.
No, this is a great discussion to have.
Isn't that just the definition of a creep fault? How does that differ from a creep fault?
I don't know. Maybe what's the speed of how fast does something have to be moving? This is a great discussion.
That's a great question.
Yeah.
What is the speed that something has to be moving to be considered? Well, so Jesse, what is, like, I guess, is it a creep fault? I'm not really too familiar with the term creep fault. Is that just when it's just like something that just very like the faults is the displacement along the faults is moving at a very slow pace?
Yeah, it's creeping. It's just not like it's
creeping it real.
Creeping it, yeah. So the way a creep fault, in my understanding, and now I'm no seismologist. So a regular earthquake, right? It's a stick slip mechanism where you have friction that causes you have movement along a fault. That's the definition of a fault. But the reason you get an earthquake is that friction causes that fault to get stuck. Now, plate tectonics is still moving the plates either in opposite directions if you're a transform or whatever. So we pretend we're a transform, moving in a plate tectonics wants to keep them moving, so you build up energy until you break that frictional hold and they slip and then they get stuck again.
Mm-hmm.
Now in a creep fault, I was always under the impression that you don't have that frictional component. You just have slow motion movement.
And
so I'm on the USGS website right now, and they have the definition of fault creep, and it just says basically what you just said, Jesse: slow, more or less continuous movement occurring along faults due to ongoing tectonic deformation. faults that are creeping do not tend to have large earthquakes. So yeah, it's more or less, it's interesting, more or less continuous movement. So
Yeah,
let
it's
me-
like a slow grind.
So maybe what this is, instead of being a true creep fault where it's continuous, this is just it's sort of like a stick slip where it releases,
But it's
that
very
release is drawn out over 2 weeks and then it gets stuck again.
yeah. So the stress doesn't have time
so
to build up.
it sounds like it's like in the middle.
Yeah, it's like
kind of.
that.
It's not a quick release earthquake, but it's not that creep fault. I just sent the link in the chat just
Yeah,
now.
it's like that quote from Einstein. You put your hand on a hot plate, and a minute seems like an hour. You put your hand on a hot woman, and an hour seems like a minute.
I don't think that's exactly what Einstein said.
Oh, come on! I'm pretty sure it's what he quoted.
It was along those lines, but you may
Yeah.
but
that's what. But see, like you have a lot of friction build up over a short amount of time and released. You're going to have a big earthquake. You have a little bit of friction constantly being released. Yes, it's the same amount of energy being released, but you're doing it in tiny little increments.
yeah, and that's
Mhm.
where earthquakes, that's where the damage comes in. They're so sudden, they release all of that built up energy instantly, which shakes it.
Mhm.
So I guess
Yeah, if you've ever been shot with a rubber band, it hurts. If you've ever been shot with a big rubber band, it hurts more. Like if you're
Where are you
building
going
that-
with this?
if you're building up that stress over a longer period of time, a bigger rubber band, and then you let it go, it's going to hurt more than if you get shot with one of those like little, I don't know, like braces, rubber bands or something like that.
Wait, so are they saying they can predict these things or what? I didn't read. You sent me that link and I just posted it, but I didn't actually read it because I don't know.
Yeah.
Well,
I never learned how to read.
So they're
Oh,
getting
saying
there.
the slow
Yeah.
ones are.
The slow ones. Yeah. There's a bit of predictability. No, I don't think it's like predictability. Like, hey, obviously. I mean, I just from what I've read on this, it doesn't seem like it's like, hey, it's going to last for this amount of time on this day at 2 p.m. in the afternoon. But it's there's an element of predictability with these slow moving earthquakes. So these slow slip events is what they're called, and they're first noted 2 decades ago because of geologists started using GPS units on these faults, and they're moving like really really slow, like really slow. I don't know.
Now, there's the video they post is really cool where they show the transfer of energy across the whatchamacallit.
Yeah, and that on the website, yeah, they have a video. We'll post this on the Flannelcast website after we get done doing this today.
The Flannelcast After Dark. That's the Patreon membership. Check us out.
Anyways,
do you have something else to add here? Because I was thinking about earthquake predictions.
Well, so yeah, just a couple more things. So they basically figured this stuff out. They can now with the modern day GPS units, geologists can see these very minute shifts, and these slow slip events do not occur along every fault. But they have spotted a handful of locations, like I said, the Pacific Northwest along the Cascadia, in Japan, Mexico, and also New Zealand. We see these slow slip events. So
Now,
the seismologists are saying it's a way to kind of fast forward on the loading / slipping process that drives the earthquakes. So it's really cool because in a short time frame of like 10 years, seismologists can basically see this cycle repeat itself several times.
Whoa.
Whereas like normal earthquakes, you might have an earthquake and then the whole thing like kind of locks up for decades, if not hundreds of years.
That's cool.
Now, is this rock type dependent? Is this
they don't get into that. They don't.
Okay.
They don't.
I wasn't sure if it was rock type or if it's the fault type or if it's a little bit of both.
That would make sense, right? Because that.
So these are subduction. I mean, the Cascadia is a subduction zone. So
so is Japan. So is some of Mexico.
When you
west coast of Mexico. Yeah.
When you think about big ones, the largest earthquakes, 8.5, 9.0. They're all subduction zones. So there's a lot of thought that Cascadia is sort of going to be the area that's hit hard. We always think about like Southern California when we think about earthquake and earthquake risk, but the Cascadia fault is sort of an area where a major earthquake could really have a devastating impact.
Plus the tsunamis.
There's always those. They're always.
I always so just imagine this. So you get rocked by an earthquake. Say there's like a 7.0 like monster earthquake. 7.0 is getting up there, right? So you got a 7.0 earthquake. Buildings start to fall down, and you manage to survive that earthquake. And you're like, "Holy crap! Oh, I can't believe you're probably still in shock." And you look around. There's damage everywhere, and then the water starts coming in.
What a kick in the pants!
Really, because that's when you're like you're most vulnerable. You're just like, oh my god, I just survived this earthquake, and now this giant tsunami surge is basically inundating the land, and that's got to be the scariest thing. Like I can't even imagine with the tsunami in what was the tsunami in Indonesia? 2005,
2004,
December 26th, Boxing Day. Yeah,
that
was the scariest.
I watched that semi-live.
Yeah, I did too. It was
really
terrible.
Yeah. I was like awake. It was 1 a.m. or whatever here, and for some reason I was just up and breaking news. They cut into all the channels with it and whatnot.
That was a scary one.
It was pretty awful.
You know who would be safe in that scenario? Steve, can we get a text alert? 7.0.
Hey, full circle. Am I right? Yeah.
Very, very good. Very good job on it.
I'm pretty high topographically. I think I'm several hundred feet above sea level.
From Seattle?
No, I'm saying let's say the Canary Islands.
You're in Pennsylvania, but
let's say the Canary Islands collapse and then a tsunami's coming towards the East Coast.
You're probably 150 feet above sea level right now.
Yeah, I'm all right. I'm really close to the highest point in Delaware County, Newman University.
Wow, that's saying a lot because the highlands of Delaware County where you're at.
Hey, listen, don't you bust on Delaware County.
The air is thin up there.
This is my Delco hat.
So I remember Nova had a special about earthquake prediction years ago. I want to say the 90s. In my head, when I replay the clip in my head, it's very poor quality, VHS quality, as is most of my memory. So I assume it was from the 90s.
So you get to adjust the tracking and everything like that in your memory.
Justin needs a Memorex memory.
Yeah.
For the kids that were born after year 2000, they have no idea what tracking is. And we just sound like old farts when we talk about that.
Or VHS or
VHS.
Laserdisc. What?
There was a retired seismologist. He might have been like a professor emeritus too, which I don't know. I guess they get bored if they got nothing to do. And he thought he could predict earthquakes. And he actually, he got Loma Prieta, which was 89. Either Loma Prieta in 89, which was the San Francisco World Series earthquake, or Northridge in 94, which was in LA. One of those he predicted like within the day. And his method, which will no longer work, was based on looking at the newspapers.
I can't wait to hear this.
Going to the lost and found.
Oh, the dogs.
And he would look.
Dude, That's my next story. That is my next story. Shut
Oh,
up. Don't talk about this anymore.
It's crazy.
Well, they've advanced on this technique. I just read about this just like literally an hour ago. So hold that thought. All right, hold that thought about what animals do. That'll be a good transition until to where I got one more thing to say about this earthquake, and then we'll move on to that next one, and we'll just let Jesse go off because I'm sure that he's got just gems after gems up in his brain right now about this. All right. So, anyways, about these slow slip events. So, the geologists are saying that if they're trying to compare these slow slip events to like regular earthquakes, and if their analogy is correct and how these things work, then they think that there might be a possibility of predicting normal earthquakes, but they might be very short on the order of like seconds. So if you can predict an earthquake by seconds, that's not, just imagine if you get a text, say you can predict it by 30 seconds. Like let's do a little thought experiment, right? You predict, whatever the USGS says, oh, there's an earthquake. Let's just say 1 minute. Just think of 1 minute, right? So now the USGS gets whatever reading, like, all right, you got this earthquake's going to happen in 1 minute. Then it's got to go through some kind of emergency system to text everyone or have the things go off on your cell phone about the earthquake. All right. So however many seconds that might take, because you ever sit next to someone and send a text message, there's like a couple second lag. If even if you're standing right next to each other, it might take 5-10 seconds. So let's say there's a 10-second lag between when the text message leaves and it gets into your phone. Now you're down to 50 seconds, and it says duck to cover, or whatever, get underneath a table or something like that. I guess a minute might it would take you a couple seconds if you read your text message immediately. If you happen to have it in your hand, then you would see it, and you could it's still going to take you a second or two after that to react to this.
Right.
But if the text message is in your pocket,
but
you got to get to
that. That's on a personal level. But think about it on a broader sense. Like, say you're in LA, and LA is, very adept to the hazards of earthquakes. If the USGS can put out an alert a minute ahead of time, then the LA like traffic center can make all red lights red. So everybody stops driving. They can stop every single train so the trains won't derail. Like in a minute,
slow them down.
Right. But in a minute, a lot can happen.
Yeah, I mean, that's...
and even
sure.
if you're saying like a minute and then 50 seconds and then 40 seconds and then
I just used a minute as a thought experiment. What they're saying is it might just be a couple seconds. So let's just bump it up to 10 seconds. What are you going to do in 10 seconds?
Japan
kind of SOL
does this, right? Japan, when their seismometers detect seismic events. I'm a geologist. Seismometry. In that region, like the gas line shut off.
Yeah,
they learned from Kobe in 1995, 96 when half the city burned down, and so like the gas line shut off. Like alerts go out on the TV, go out on the phone, because even it is good thought experiment. People do this for like, there was a professor who taught this, and he would either send out an email or he would send out a text, and he would be like, all right, stop what you're doing right now and think about what your escape plan is for like 10 seconds from now. Like he would do that, and there isn't necessarily much you can do in 10 seconds, but it also gets you to start thinking about like, how do I react in these situations?
Mm-hmm. And all those students became doomsday preppers.
Yeah. They live in a bunker. They joined a cult and they live in a bunker.
Exactly. But for instance, like I have gas in my house, I know exactly where the gas shutoff is. Like I know if there's an event, how to go outside and how to turn it off. And
Is it lefty loosey, or is it a reverse from turning the gas?
So it's really just a quarter turn. So if your pipe is going this way and the valve looks this way, that means it's on. So you just have to turn it a quarter turn so it's going opposite way of the pipe. So it is righty tighty, but
okay.
If for some weird reason it doesn't go that way, try the other way. But yeah.
Not that I need to shut off my gas.
No, and I have a shut off inside my house too.
Oh, really? I don't have that. I got them on different parts of the line.
I have one main right here in the heater room, so I can turn everything off. But
we've diverged a little bit here.
Yeah, but I'm just saying, like emergency plans. You know,
that's a great.
Yeah,
yeah.
I don't have like a go bag, like a tent and an axe in a bag with like rations. Oh, jeez, Louise.
It's.
Is it just full of scientific papers in a granola bar?
It's full of a book by a 19th century photographer who took pictures of coal mines.
He is all about the coal mines over there. He loves it.
I got some pink duct tape. I got some sample bags.
All right.
Yeah. No, I want to show you everything.
Okay. Hey, real fast announcement to all the people that are watching us live right now. I know I put it up on the chat, but if you have any questions, put them in the chat. We can play Stump the Geologist later on in the show, or as they come along. This ought to be good. So, any questions? And also shout out to our buddy Matty. He's watching the show right now.
Matty's listening. Hey, buddy.
Matty's listening right now, and let's see, Mark, what's up? And Love to Destroy, what's up? Throwing some shout-outs
Love
right
to
there.
Destroy.
Yeah. Love to Destroy is actually
Jim Manning too.
Yeah, Love to Destroy is actually the earthquakes. Like getting tips on they're catching on to how I can predict things. Gotta get
that could be it.
All right. So there was a little talk in the chat about the animals in Los Angeles going off. Let me so Jesse, continue. While I pull up my notes for this story, actually I have them right here. What so you said that there was somebody that would just this person would just watch the class, not the classifieds, but like the ads or whatever in the newspapers, and just say see missing dog and things like that, and they use that to predict earthquakes.
So from the Nova special, I don't know too much. Yeah, Mark in the YouTube chat said in LA this was common. People talk about animal behavior. So there was this guy from the Nova special named Jim Birkeland who would.
It's amazing you remember the name, by the way. That's very impressive.
Well, it stuck out, but I also looked him up in the interim too.
Is there a textbook by Birkeland?
This is Birkeland with an E, B-E-R.
Thank you. All right.
Yeah, the soils textbook, right? But he trained at Cal Berkeley as a geologist and worked at the USGS, and was like a legitimate geologist. But he was also, and I'm quoting from the Wikipedia page here, disputed by his peers, with people calling him a crank and, quote, a clown, which is just a great insult when you're trying to.
I've never been called a crank or a clown in my life.
I was just going to say, to my knowledge, I haven't been called either.
That's the greatest compound insult ever.
I've definitely been called a clown. I don't know about a crank. A shout out to Jim Manning on YouTube, because he's definitely been called a clown too. I know that for a fact. But he was all about predicting earthquakes, and he had a number of ways, and it's probably why he was called a crank and a clown. He was always looking for things, including like the Earth's tides. Which, man, people have been trying to say tides moved the plates around since Wegener's day.
Oh yeah.
And the tides just don't got the energy.
We'll talk about tides actually for another news story.
Sweet.
You really, this is amazing. I didn't show it, but for the people listening, I did not show him what my news stories were. This is like a surprise for these guys. And
I also, first off, we should have checked what our animals were doing before we synced up like this. All of our pets. Is Muggins around? Did your cat flee?
No,
he knows.
She's right. She's right here. She's just she's
also
chilling. She's waiting.
There's some insight into how we do these news story episodes, in that we don't tell each other the news stories we have.
Yeah, it's always like, yeah, I got a couple. Yeah, I got 3. Yeah. We'll talk about it.
But the one, he would look at the newspaper and look for the lost cats and dogs, and he would track, and he did like the statistics of it, and apparently he would see an uptick, a significant uptick, where it'd be like, 4 lost dogs, 33 lost dogs or something. He would see like a significant
yeah, so that's a thing that's people have noticed, but from my understanding of this, there's never really been any like hard statistical evidence of this stuff, right? Until here we go. All right. So as part of an international cooperation project, researchers from the Max Planck Institute of Animal Behavior in Constance Radolfels, I don't know how to spell that. I pronounce it. Excuse me.
Why would you try and go for the hard words like that?
Whatever. Some people looked
There's
at this. So I'll post a link.
There's a Max Planck research facility for pets.
Animal behavior.
Yeah,
Max Planck
because the Physics Institute is like
the Planck constant. Yeah. Anyway, carry on.
Says, but so at the University of Constance, they investigated whether cows, sheep, and dogs can actually detect early signs of an earthquake. So what they did was in northern Italy, where it tends to be an earthquake-prone region, they recorded the movements of these animals over several months. And so what they did was they attached accelerometers to it says one farm. So they attach accelerometers to these animals. All right. And movement data of these animals shows that the animals were unusually restless in the hours before the earthquake. And the closer the animals were to the epicenter of the impending quake, the earlier they started behaving unusually. So they start, this is really cool because they're actually using, getting actual real data and seeing how much these animals are moving around. So it says the movement profiles of different animal species in different regions could therefore provide clues with respect to the place and time of an impending earthquake. So, there's been a long time, we just been talking about, for ages, people have always talked about how animals start to get a little restless and pets kind of run away, but it's all been anecdotal accounts.
Yeah, since at least 300 BC.
Yeah.
The Greeks wrote about animal behavior before earthquakes. Fun fact.
The Greeks, really?
Yeah.
Wow.
You've heard of them?
I've heard of the Greeks once or twice. Yeah.
What have they done for me lately?
Great point.
I'm sure they've done great things lately.
I got nothing.
Don't want to alienate an entire country on this podcast. So
again.
So a lot of these earthquakes, they noticed they're up in northern Italy. And during the time period there's that they were looking at, there was over 18,000 earthquakes in the region.
Whoa.
Over several months. Yeah, it's a lot. It's a very tectonically active area, but most of them weren't there. They weren't very strong earthquakes. Most you wouldn't even notice of them, and only 12 of these earthquakes had a strength of 4.0 or higher on the Richter scale. But what the researchers found was that the unusual behavioral patterns started about 20 hours before an earthquake. And like I said, the animals that were closest to the epicenter of the earthquake changed their behavior, and that's what you expect. And the further away you got from the epicenter, the more the behavior, the strange behavior decreased.
So do they account for what changes their behavior?
Well, that was the thing. They don't know. There was I got to pull the article up. I'm just reading off my notes right now. There's a couple things that I think there were some potential hypotheses on what changes the behavior. But
that's interesting. I'm wondering if I'm going to entertain this idea, which I am. I'm going to become a crank and a clown. I wonder if it's like
you've been a clown for years, so I don't know why this is a big deal.
A lot of times they think like, maybe as the strain is, as the stress is building and it strains more, you get like low frequency rumbling, or they can pick up sort of these lower frequency vibrations or sound.
So 2 things real fast to add on to what you just said. Number one, just to kind of finish up the story, the researchers found out that you can't look at individual animals. Individually, you can't tell, there was no strange behavior before the earthquakes, but collectively you could see the strange behavior with these animals. And also the article, or some of the hypotheses put out there are that animals might sense ionization of the air caused by the large rock pressures. So what do you guys think about? It's either that, or they think animals can smell gases released from quartz crystals. I've never heard of that before. I never heard of that one before.
I was entertaining a lot of that.
What do you like? I don't think. Well, I know that they've seen earthquake lights before earthquakes. You guys ever seen those videos?
Yeah. You're getting into the realm of like the Tao's hum.
The fringe stuff, right?
Yeah. Which I am all about. Like I said, if you want to go squatching, is that what they call Sasquatch?
Yeah. I'm in.
Got squatch.
I'm open
I don't
to
know.
all.
I agree with Jesse. I don't know, and I guess Steve, I too. I don't know about
not just gases released by quartz crystals, but there is increased like radon and things like that before earthquakes too. Because but
I kind of want to like. Oh, sorry.
No, I was just. It's hard to think of it on a human type time scale, because you think stress builds up and it slips. Like you're not thinking about all the stuff that happens when the stress is building up, and then what is happening right before the release. Something has to happen right before the release, right? Mm-hmm. What is that? Is it just you reach that breaking point, you're building up stress and you reach a breaking point? Because that's kind of what we're taught. Like it builds up, can't hold it anymore and slips. But what is it that right before they can't hold it anymore that's happening that these animals are detecting? And I don't know. Maybe it is release of gases. Maybe it is some sort of low frequency hum. I don't know. Maybe it is the northern lights coming out of the ground, or whatever. What were you calling it? Like earthquake farts or something?
Yeah, you should get in. You want to go down a YouTube rabbit hole?
Yeah, we can call it earthquake farts, and we'll just.
That's
no.
No,
you can call them earthquake farts. I mean, sure, why not? Earthquake farts. There you go.
Yeah.
Once this all ends, the world. Once we can,
and all that's left is the artificial intelligence watching these podcasts.
Once we can be socially close again, we should take a road trip out west and just like record from like the high desert, just videoing, like looking for UFOs and earthquake lights out in the desert.
I like it. So I'm sorry, I'm not familiar. What are earthquake lights?
It's just so it's like these like rainbow lights that kind of come out of the ground, and the hypothesis is I think they've recorded. There was for a long time. I know there's YouTube videos from China of these earthquake lights. Now, once again, this is like so far out of my realm of expertise and just regular knowledge. But from what I've seen, these earthquake lights, like I said, if you Google or if you go on YouTube and just check out earthquake lights, the first thing that'll probably pop up is this video from China, and it's just like these rainbow colors coming out of the ground, and it preceded earthquakes by I want to say like an hour or something like that, and they think that the as far as I know, the hypothesis was that it had something to do with the strain on quartz and the piezoelectric property. Is that it? Piezoelectric properties of quartz?
Yeah.
Is that
Yep.
the piezoelectric properties of quartz cause these colors that we saw? And I don't know the physics. Don't ask me about the physics on
Are you sure it just
on
wasn't
how
like
that works.
a Skittles mine?
Either that or there's probably some mushrooms involved. No, I'm joking. No.
Yeah, they're just tasting the rainbow. What? Skittles.
But that's that's the thing with the earthquake lights. It's I mean, it looks crazy, and for the longest time it was never caught on video, but yeah, they got something on video, and I mean, I don't know.
Yeah, I'm gonna need a little more evidence on that, but again, I'm open for suggestion. If you can actually prove to me, there's got to be a way to recreate that in a lab somewhat.
I mean,
could you just like squish
what if you just need like
rocks?
such? But what if it's just one of those things where you need like an intense, like such a tremendous amount of pressure over like a large area?
And
the
area,
like
the area
volume
you can't really,
you
can't really repeat that in a lab. But yeah, hey, what? That's what I'm saying. I'm saying
You're all in now. You believe it.
Open to interpretation.
It's the only explanation that makes sense anymore.
Aliens, man.
It's probably alien. No. Wow. Even I Googled it, earthquake lights, and the USGS has
earthquakes.
I Googled
earthquakes. I got a better understanding now.
No, I mean like all right. So the USGS has a website about earthquake lights. What are
really?
earthquake lights? Yeah, I'm dead serious. Can we read it? This is a short little paragraph.
Yeah. Okay.
Phenomena such as sheet lightning, balls of light, streamers, and steady glows reported in association with earthquakes are called earthquake lights. Geophysicists differ on the extent to which they think that individual reports of unusual lighting near the time and epicenter of earthquake activity represent earthquake lights. There's some doubts on the reports constitute solid evidence for earthquake lights, whereas others think that I can't read. Others think that at least some of the reports plausibly correspond to earthquake lights. Here you go. Physics-based hypotheses have been proposed to explain scientific classes of earthquake light reports, such as the immediate vicinity of the causative fault at the time of a major earthquake. On the other hand, some reports of earthquake lights have turned out to be associated with electrical arcing from power line shaking. Well,
This article brought to you by the U.S. Air Force. Please don't look at the weird lights in the sky.
Nothing to see here.
Nothing to see here. It's all earthquakes and electrical arcs.
So basically, yeah, the USGS site says maybe, maybe not.
Yeah. We should get
but
Kelly
they acknowledge it, and that's what the alien people are all about. Just
we'll
the fact
bring Kelly
the Pentagon
back on and be like, I want to talk about earthquakes and lights and dogs and aliens. She'll be like, please don't ever call me again.
Yeah, she will quickly block our numbers. All of us, all three of our numbers.
All right. Flannel who? Yeah.
Yeah. All right. Well, that digressed rather quickly.
But come on, like that just proves how much we don't know about things.
No, we know nothing about how the Earth works.
We know a little
I
bit.
mean, okay, a little bit. I'll take that back. We know a little bit about how
Let's
the
keep
Earth
some of
works.
our listeners here, Chris.
No, but relatively speaking, like there's just so many variables on how Earth processes work. It's oh man, it's so hard to figure some of the stuff out. I mean, some of the stuff, yeah, you can figure out, but other stuff, it's you talk about like such like gargantuan topics like plate tectonics. It's like it's so much work behind what we know already.
It's funny
just to figure that out.
Today I was in the car for for a significant portion of time, other than like to the grocery store and back, and running through my mind was like chaos theory math about how basically most things you might think are just totally random could actually be predicted by chaos theory math. It's just there's so many variables involved. It would be hard to capture all the variables. So, for instance, earthquakes, like if you knew exactly how much stress was involved, what the perturbations on the fault were, what the rocks on the fault were, what sort of stress regime they can handle, what sort of stress regime they can't handle, how much liquid is involved in the fault. Like if you could wrap your mind around the million different variables of a fault and where you think an earthquake might happen, you could probably predict it. The problem is collecting the data of the trillion different variables is essentially not realistic right now, but it might be in the future. Like with the artificial intelligence and things like that, like how?
Yeah, the physicists. If we had a physicist on the show right now, they'd crucify you for saying that.
I don't know. Like artificial intelligence, they repeat something and they figure out what was wrong with it, and then they.
I don't trust computers.
That's good. As this whole thing is being broadcasted via computers, you have no trust in any of this stuff.
You won't hear from me after tonight. They're gonna. Doors will just lock behind me. I won't. Yeah. No, that's true. I mean, that's getting to the whole heart of, I guess, prediction. If you know all the variables, it makes it much easier.
Right. It's just I guess what I'm saying is taking getting through your mind the difference between random and actually not really random. You could predict it if you had enough data points, like flipping of a coin.
There was I don't think that you can do that, and I want to say I'm going to say that because I read one book. And
oh boy! Well,
this is going to be good, right? No,
Humpty Dumpty sat on that wall.
Really,
come on.
Humpty Dumpty had a great fall.
I'm more of a well. Anyway,
one little digression, real quick. At no point in that story, Humpty Dumpty, did they ever say he's an egg.
That's mind blowing right now.
Whoa.
Yeah. I that's it. Thanks for listening, everybody. This has been a great episode.
Sorry, right? Like they never talk about him being an egg, but every single depiction of it is he's an egg.
That's weird.
Yeah. Carry on.
Yeah. I don't know how to follow that up.
I want to get into that a little bit because I'm going to look into that because like 6 years ago, I bought a book of Grimm's original fairy tales. Like,
yeah, they're awful. I have
they're
a
really
few books
violent,
on my
right?
shelf right here.
Yeah. And then that took me down a rabbit hole of looking into like how these stories, where they come about and whatnot. Man, stories back in the day were dark.
Yeah.
Dark.
Well, I mean, movies we watch today are dark, though. I mean,
Yeah, but Cinderella, like in Cinderella, it's like, oh, Cinderella, oh look, this shoe fits you. Like, and the
No,
real
but isn't like
Cinderella's
that's
Grim
like the
Cinderella,
Disney
they're
stuff.
like cutting toes off and cutting
Yeah.
heels off and blood. And
There's
Crow's like, look at the blood.
a lot of gore.
Yeah.
Yeah, everyone's getting
Yeah.
like they do wrong and they're getting killed. I bought it too
Yeah.
because I was like, oh, I'm gonna teach my kids the real fairy tales. I'm gonna go old school. And then I remember like reading a few of them on the train. I was like, oh no, they have to be like 18.
No, I'm gonna
before
shelter
I
my
can tell-
kids. Yeah.
This is R.
So anyway, I'm sorry, Chris.
That took a turn.
Yeah.
Yeah, I don't remember
All right,
what you're
so
talking
we-
about. Humpty Dumpty.
Yeah.
That's all I remember. My mind
Something like
erased
that.
after that.
All right. So do you guys want to do another news story? We got some listener questions.
Well, you were talking about plate
on the
tectonics.
chat.
We can step into the plate tectonic question here about the old LLSVP, as the kids call
Yeah,
it.
you want to?
That's the kids call it.
Yeah.
Yeah.
Can the kids define that for me?
So that would be large, low shear velocity province, otherwise known as I always knew it as the plate graveyard. So it's at the core mantle. So at the core mantle boundary, we see these weird seismic anomalies. So a lot of times at the core mantle boundary, you'll see referred to as a transition zone.
Right.
It's not a sharp. It's sometimes called the old D double prime.
Mm-hmm.
And so, you would hit this interface because you're going from rock to molten outer core. So you're expecting to see a slowdown anyhow.
Yeah, something.
But yeah, you see a lot of, I don't know how to describe it, squishy parts.
Yep.
I was trying to go with
Slushies. I got it.
Yeah, I was trying to give you the real term there, and I fumbled over it. So I just turned on a dime. See how quickly I turned? Anyhow,
Very good.
one of the you see connection. You see a lot of times these plumes that come up from these LLSVPs, which really just flows off the tongue.
Yeah, it's really yeah.
And so there's some thought that, this actually ties into, I think we talked about this off the air last time. So when plates subduct, you're always taught that they just reincorporate back into the mantle. Whenever we draw it on the board, we're just like, yep, they recycle right here. Boop. Never to be thought of again. But there's a lot of thought that actually a lot of these chunks of oceanic crust don't reincorporate. The density of them causes them to sink through essentially the semi-solid mantle until they get to the deep mantle. And that's what you're looking at. You're sort of looking at these really segments of crust that have basically sunk all the way down to this transition zone. But we did talk, there was that story last week, and I've closed the tab, so I can't tell you much more about it.
You closed the tab?
Send it to you
I
real
did.
fast.
Yeah, I did send it.
We didn't talk about it. We talked about
Yeah.
talking about it
But
before
then we-
we went on air.
And
But
then we
the-
talked about
But
talking
actually,
about it.
so that one actually no. So that one that we recorded, what we're talking about last week, isn't coming out until next week. FYI. So nobody's heard about this.
Oh.
Double
that's episode
double
52.
spoiler
Yeah, yeah.
alert.
So episode 52, we actually, we don't even, we wanted to talk about this topic, but we never got to it. We had other topics that we ended up covering, but
All the things you can learn if you become a Patreon, right?
no,
you
that's
get-
not even a
you get-
Patreon. That's just like
Shh.
everybody can get this for free.
Chris.
All right, I'll just be quiet. I'll just sit in the back here. You go ahead. Have fun with your podcast, everyone.
What I was trying to say is
this is our teaser that there's some new evidence that maybe some mantle recycling does happen, because I was
or doesn't happen.
or does it?
Yeah. And no.
We just
Right,
keep going
right.
back.
That's what I'm saying. We were taught like, oh, here it goes down and it gets recycled. But what you're saying is it doesn't really. It just kind of
Oh well, so
sinks
no,
down and dies.
yeah.
So let's take a step back for the people that have no idea, like for the people that aren't geologists. When you have two plates colliding, let's say you have a continental plate and an oceanic plate. When they collide, the oceanic plate is denser and it gets subducted. It gets shoved down, right?
Yeah, it's
So
usually older, colder, denser.
Yes, exactly. Yeah. So that happens, and the question has always been, well, what the heck happens to that plate after it's been shoved underneath the continental plate? Does it go down? What happens when it goes down into the mantle? Does it just kind of just kind of fall off down there, and what some people have called a slab graveyard, or does it like get recycled? And there was a story out last week. We actually didn't even pick it up for the podcast, but we were kind of talking about it. But there's some evidence, and I forget off the top of my head how they were looking at this, but
it was geochemistry of the.
Was it strontium isotopes?
Yeah, strontium, and there was another one.
I don't remember. I had to look at it. I could send you a link right now if you want. But yeah, they're at these mid-ocean ridges, right? Like for example, like where the Atlantic Ocean is growing, it's spreading and it's spreading up. I guess it is spreading apart. And right down the middle of the Atlantic Ocean, there's something called a seafloor spreading center. It's also known as mid-ocean ridge. And these geologists were finding evidence of these recycled plates that had been subducted down that were now resurfacing and being recycled. So essentially, it was plates got pushed down and it's turning into new rock now being formed at the bottom of the oceans. Did I butcher that?
No more than usual.
Jesse's quiet about it. No more than usual. Here, I'll send the link. I'll send the link over to Jesse.
Yeah, they're seeing there's a geochemical signal where they're seeing like pieces of the old stuff coming back up. So it's, in my mind, it's probably a little column A, a little column B.
Yeah, I was going to say it's got to be a lot more complicated than just.
Yeah, it doesn't have to be one or the other.
Yeah.
Mm-hmm.
And
wow, surprise! Science is more complicated than we thought it was. Wow,
but also the cycles, the timeline of these things.
Just send it over.
The timeline of these things are, on the orders of
a really long time,
if not hundreds of millions of years.
So there's a lot of thought that these LLVP, whatever, the
LLSVP.
The blobbies.
What is it? The superplumes is what they're called. Right?
Large low shear velocity provinces.
Woo, superplumes.
So there's a lot of thought that the crust we're seeing down there now is we're talking like hundreds of millions of years. Like
right.
What was that, Rodinia or something like that? Like crust, as I know it, crust from back in the day. Right. So, but
back in my day, it was called Gondwana land.
Yeah, I'm okay with a slab graveyard. I always like that explanation. It's a sweet name. It'd be a good band name too.
It would be Slab Graveyard.
Slab Graveyard.
My favorite is the nickname for the Permian Triassic extinction event, the Great Dying. That would be such a good thrash metal band.
Or
Death Assemblage.
Death Assemblage.
Death Assemblage. That's my second favorite one. Yeah.
What's Lagerstätten for all our German fans? So I'm on board to answer the question from the YouTube chat. I'm on board with Plate Graveyard. Done.
Yeah.
Put a pin in it.
Done.
No.
Answered. Mic drop. Except please. we're not gonna drop these mics because we can't afford that.
Yeah, please don't. Please no follow up questions.
We don't want to pull a Kurt Cobain on our equipment tonight. That's
No. I don't even know if people know who Kurt Cobain is anymore.
Oh, come on. I was literally just listening to In Utero right before the podcast started.
No, listen.
My favorite Nirvana album.
We're old people. And that is appalling that In Utero is your favorite album for
What?
Nirvana.
Dude, come on. Nevermind is just like this commercial piece of trash.
I would take Bleach over In Utero.
All right.
I never really cared for Nirvana. I'm going to mute all things from now on.
So Chris and I are just going to carry on this podcast by ourselves.
He really did mute himself. He's not joking about this.
No. I don't know how to respond to that. Like, honestly, like Nirvana had a pretty profound effect on my adolescence. It wasn't even adolescence.
This is a controversy that you totally brought up, by the way.
I understand. So I guess, I don't know if I'm slightly older than Chris and Jesse. So I was 17 when Kurt Cobain killed himself. 16, maybe.
Allegedly.
Yeah. Sorry. So.
Oh shoot! I forgot I was still muted. I was talking there.
Oh yeah, but so the very first CD. So I went to the mall. Back for those of you who are listening, a mall was a big building that had multiple shops
before Amazon.
Did you go to the wall at the mall?
Sam Goody?
It might have been Sam Goody.
We didn't have Sam Goody. We were
actually it might have been wall to wall sound and video before it was the wall. Yeah,
dating
that's
yourself.
Right. That's how old I am. So
I don't even remember that one.
I
remember Sam Goody turned into coconuts.
I wish I had it with me. But when you bought CDs, they had these big boxes. Do you remember the big boxes?
Wait, what?
No.
We lost you. You cut out there for a second.
Yeah, your sound went really down.
Big boxes.
Do you remember
when you pulled the CD out? It was
when you
big
bought
plastic thing.
No, but when you bought a CD, it used to come in a big box.
No, they always had the little tiny the CD jacket.
No, it used to come in a big CD box.
What is this?
I feel like you can only get that if there was a special limited.
No, so this was a thing when CDs first came out, and then they realized this isn't really environmentally friendly.
They were probably like, it costs. We could save 5 cents on the production.
Exactly. So, my first 2 CDs I ever bought were Pearl Jam 10 and Nirvana Nevermind.
Sure, I like Pearl Jam. I don't know. I was 10 or 11 when Kurt Cobain died. So,
I think
I was 16 or 17. So, anyway,
you can do some subtraction there and figure out how old Steve is right now.
42. My age. I was born in the 70s, fellas. All right.
Wegener's field assistant, or some thought he killed Wegener.
I barely made it out of Greenland.
Wow.
Oh man, that'd be awesome.
All right.
Terrible. That would be terrible.
Aside from Wegener dying, but I mean,
yeah, I kicked him in his shins and carried on with his food rations. What do you want me to say there?
Take a sweet pipe, his tobacco pipe, and anyhow,
you guys. You want to cover this second question, Jesse? I feel like this second question's up your alley.
Oh God, it is, but I feel like I'm not prepared. All right, so the question about the PETM now, which is
Paleocene-Eocene Thermal Maximum.
Oh man, great one.
Come on,
great one.
You haven't lived until you've learned about the PETM. Whew.
And this was 30. I always mix this up. 35 or 55.
55.
55. Thank you.
Just think it's all fives. 55.5.
There you go.
A million years ago.
So the PETM was a dramatic spike in warming, and the warming was anywhere from 5 to 8 degrees Celsius.
He's so hot right now.
Which is anywhere from 41 to like 47. No, sorry. Yeah, 5 to 8 degrees Celsius, 41 to 46 degrees Fahrenheit hotter than today. We got some angry messages about when we talked about the cooling during the Carboniferous.
Just remember, Jesse, we can't edit this out right now.
I know. I just want to. I think it was a reasonable
mistake.
The person who sent us the message, it was reasonable at first. The end of it was unnecessary.
Oh, jeez.
Yeah.
Continue. Just talk about the
anyway.
the PETM.
I want to acknowledge this.
No, that's true. Like, hey, listen, if we ever get something wrong, we always want to know. Please give us a comment.
Part of the thing, though, was we weren't wrong. We just, the way it was interpreted, we said it was, I don't even remember. We said it was 15 degrees Celsius, which is 59 degrees Fahrenheit. But it was 15 degrees cooler, which means it was 59 degrees Fahrenheit cooler than present. Not that it was 59 degrees during the Carboniferous glaciation.
Got it.
Anywho, so the PETM is making Chris very uncomfortable, confronting our detractors.
We love everyone. We're all friends. We're all friends out there.
Yeah.
Every person we've ever had a comment from has always been mostly been like, hey, listen, I really think you got this wrong. I have no problem. And we're always like, hey, gosh, that's great. Yeah. Like, yeah, we'll address it. We'll figure it out. We'll correct it. But
I strive to, like, I assume, like, a lot of us, especially in the science, like, I have this inherent fear of getting something wrong. And especially, like, when I'm lecturing about something, like, if I'm teaching a topic, even if I'm telling an anecdote, which is 95% of my teaching, like, I want to make sure my anecdote could be about, like, the Vikings in the 10th century, and I'm nervous there's going to be some random person, in my class.
All of a sudden, your student named Ivan is like, wait a second.
It wasn't the 10th century. It was actually the 11th. You're way off.
Yeah.
And then I'm like, I'm teaching freshmen in college who are half paying attention. Like,
and actually, if he's a Viking, his name would probably be Thor. It wouldn't be Ivan, but that's semantics, It
is semantics. Well, this is going to...
Ivan is a legit...
Yeah, because
Ivan's a Russian.
No, it's
Eastern European.
Well, no. So
I feel like there's
Vikings. Yeah. The Rus people settled in what is today Russia. So there's connections there. That's probably going to anger
Chris. Mark this down on your whiteboard. 1 point for Steve.
I mean, there's some dispute there, and that'll probably anger most of our Russian listeners. But anywho, the PETM, which is where we started this,
yes,
way back.
I can't believe we digressed. That's so weird.
What's funny is when we started this, you're like, "You have any news stories?" You're like, "Yeah, I got 4," and I was like, "Yeah, I got like 2 or 3." I think we made it through like 1.
Yeah,
we're through 2 news stories right now and 2 listener questions.
Yeah,
we're on our second. So this is like our fourth topic. It's great. You guys having fun out there? Everyone having fun? Let us know. You having fun? What can we do to change?
Yes,
get better?
Somebody please text us.
Make it
text us.
We know at least Maddie's listening right now.
Yes, thank you, Maddie.
So the PETM,
and Maddie did text me. He said, "We all know geophysicists." So,
and we got Alex, past former guest of the show, Alex Burdenham, listening. I don't know if he's still listening right now, but
nice.
Yeah. Oh, I didn't even see his question in there. Snuck in there. How do you pronounce?
Oh, yeah, his question. Yeah. Okay. He's busting on us. He goes, "It's stumped the geologist. How do you pronounce Neanderthal?" It's Neanderthal, Alex. We learned. Thank you very much. Everyone's a joker. It's the internet. Everyone's got a voice. Everyone's a joker now. Thank you, Alex.
And we all know now they went extinct 40,000. Shoot, I forget now.
He's still listening.
Listen to our previous episode.
Shoot.
Or if you're listening, please chat it out there. Yeah.
60,000, between 40 and 60,000 years ago is the
Alex,
last evidence.
Yeah, when did the
of
Neanderthals
They
go
probably
out?
survived past the last bone and that we've found. You know, they're holding on.
Alex is sitting there at home. He's pulling his hair out.
He's still
just like,
listening.
I just
Between 40 and 60 is what I'm going to say. Yeah, 40 is right. Nailed it. 40,000 years
Is that
ago.
what he said? Did he,
Yeah, Neanderthals go extinct.
he didn't get back yet about that one, but
Yeah.
it's,
Love to
40 is
destroy.
right. Okay, confirmed.
Love to destroy, having fun. Perfect. All right, PETM, getting here. I don't. So the question we got was, how are we going to use the PETM to sort of think about the future when it comes to modern climate? And so the PETM is really hot right now, which is both a pun and a truth about research. It's a really active area of research because so during the Paleocene-Eocene Thermal Maximum, it's called, there's this big spike in temperature. And so the spike happened really sort of rapidly on geologic time scales. But in like human time scales, it was stretched out over the course of, you know, a couple thousand to tens of thousands of years where the spike occurred. It's a really short-lived spike too. We don't really understand it all that well. So that's why it's so active. You know, we have other abrupt climate events like the Younger Dryas, personal favorite, which occur. The Younger Dryas was a rapid cooling event, and that the onset of that was anywhere from 15 to 30 years. So really human timescale rapid.
Yeah, like
PETM, yeah,
volcanic eruptions. Nobody swam. It was a big deal.
yeah,
Almost like 1992.
Almost.
the summer that
Almost.
everyone remembers lacking swimming.
I think this year I'm going to remember not swimming at all this year because all the pools are closed down. But I think it's a different story. It's different circumstance.
So
because it was hot today.
yeah, so the PETM, you know, we'll say it occurs 20,000 years. Over the course of 20,000 years, temperature spikes anywhere from 5 to 8 degrees Celsius, which is enough to really cause problems. So
and 20,000 years when you're talking about 55 million years ago is like, you know, a hot second.
yeah,
Like it is super fast geologically.
super quick.
Yeah.
So, you know, there's some thought about what this would do to a climate. You know, we would see, there's a lot of thought that a lot of areas would become more wet because
Wet, yeah.
yeah, the air would become warm and it could hold more. You have increased evaporation and you can hold more water vapor. And you sort of see this by looking at some of the isotope data. But you did get a lot of ocean anoxia because you get some ocean thermal stratification, which is where the layers of water don't mix as well.
So ocean anoxia means that there's lack of oxygen. in the
Lack
ocean.
of oxygen, yeah. So and the stratification is just because you're getting these temperature layers that aren't mixing, the water's not mixing anymore to transfer that oxygen from the surface downward. So anywho, there's a lot of thought that there's going to be application for what we're seeing in current climate change, where we're seeing this rapid warming. And the short answer is it applicable? Maybe.
Now,
The mechanisms are likely, we're moving much more rapidly than the PETM did. And, things were different 55 million years ago. There was no grass. There's no, ice there's no Antarctica or Greenland. There's no ice, massive ice sheets. There's no Southern Ocean current, ocean current. So there's all these sort of, again, it gets to the idea about complexities. Our climate operates a lot differently than it did 55 million years ago.
Right.
You said, 55 million years ago, there's no grass. And a lot of people don't realize that grass didn't evolve until about 30 million years ago.
Yeah.
That always that's still you just look at it. There's so much grass out today. And it's that's, it's really geologically, it's not that old. I mean, 30 million years it's getting up there. That's a sizable amount of time. But, the dinosaurs never saw grass. That's just my 2 cents.
Except for modern dinosaurs.
No, could you imagine
birds?
Could you imagine T-Rex trying to mow a lawn with those short arms? Come on.
It'd be awful.
Yeah.
Oh boy.
You have no time for my jokes today.
Yeah,
Chris. Come on, man.
We've been here for an hour.
Boy.
I think
I don't know.
It's both.
I've been dealing with this for so many years now. Maybe it's just coming to a boiling point tonight. This is it. This is the buildup of all of Steve's whatever.
Awesome jokes is what
So
you were about
awesome,
to say.
Awesome jokes.
I'll wrap this up by saying the PETM has both application and not. Both. Yes. The answer is yes. And no.
Okay.
Like a good scientist, I'm not going to be definitive one way or the other.
No, it is a good paleo proxy. It's not a perfect paleo proxy.
No, yeah, exactly. And it tells us how different aspects of our world respond to rapid change. And I think that's something we need to evaluate.
Yes. But at the same time, it's not the same exact world that we're living in now. So it's not an apples to apples comparison.
Exactly. And the mechanism of how or why it happened is still unknown, which dun, dun, dun. That's
really?
Yeah.
Yeah. What do you think it is?
Yeah. They don't really know what the PTM was caused by.
When I was an undergrad, way back in the aughts, it was thought to be methane release from the methane clathrates in the bottom of the ocean.
Yeah, that's what I think carbon release.
And I thought a lot of that.
What about the volcanism?
So volcanism
with
the
North Atlantic igneous province.
Yeah, there's some people that love. Well, I don't know. Is North Atlantic? I guess that was them. So methane clathrates, I feel like, were popular, and then it did some studies.
Can you just explain, just real fast, what a methane clathrate is, in case?
Yeah. So at the bottom of the ocean,
we've talked about this on the podcast before, but
yeah. So in the deep ocean, in the sediment, there's basically these cages of methane that are locked up in the sediment and because it's so cold at the bottom of the ocean, 2 degrees Celsius, 1 degree Celsius. And so you have basically just these structures. So they literally look like cages where you have methane trapped within water. And so it's in the sediment, it's in these waterlogged sediments. And if you heat it up just a little bit, the thought is that it will release, it will break this cage, and the methane will basically bubble up to the surface. And methane is a super potent greenhouse gas. So so sometimes it's referred to as the clathrate gun, because once you heat it enough, it's like you pull the trigger. And it releases all this methane into the atmosphere. And it was really popular in the late aughts. And then I feel like it encountered a lot of studies came along that said, all right, there's some problems with how this methane actually releases, and they couldn't really do good lab studies to actually show it releasing in large scale. But yeah, just sort of looking at it right now, I'm seeing that there's been a few studies much more recently that say, well, the isotopes actually say it might have been a lot of methane. If I was putting my money on something, this was probably the biggest contributor. But who knows? There's people who think there's, everyone wants to see an asteroid or a comet whenever you see climate change, or burning of peat from volcanic eruption and wildfires.
Yeah.
Anyhow,
well,
orbital force.
That's a spoiler alert for the podcast coming out next week about.
Yeah, man.
Was that last week? We Wednesday record? No, wait.
That was with
day is it today?
Chris Kahn.
What days? Time has no meaning, Chris.
Yeah.
We're
This
actually
COVID
in
is
hell
killing
just
me.
recording these over and over again.
Groundhog. I saw something that said Groundhog
Right.
Day. Bill Murray was there for like 30 years.
Really?
Someone worked out like just the number of times he kept waking up.
No.
Then they went into like he learns French poetry and he learns the
No,
piano.
I see that. And he learned the piano and everything like that, but
Yeah.
I call baloney on that. Baloney.
Oh, Shaloni.
I
Anyway,
would give it a couple years for Groundhog
Yeah.
Day at most.
I don't know. I have no idea. Great
No,
movie, though.
he
Great movie.
learns French poetry, but he learns the piano too. So
yeah.
I don't really remember that. I remember the plot, but I don't remember the nitty gritty. I haven't seen
Are you
that thing
kidding
in
me? I watch it every February
25
2nd.
years.
I just love the
Course you are.
groundhog driving the car.
People that don't live
Side
in
of your eye.
Pennsylvania
Side of
don't
your
realize
Side of
like,
your eye.
they don't realize Groundhog Day.
Don't drive.
Like, they've
angry.
heard it. They've heard of it, but they don't like. It's not
Yeah.
like that's a Pennsylvania thing.
Actually,
Wake
the,
up, Tony Phil.
Pick up your shout.
The-
It's Pennsylvania polka.
Oh, I love that song.
Oh my god!
Yeah, the article I read was like Groundhog Day made famous by the 1992 movie, and I was like, whoa!
It's
Yeah.
been
Pump the
famous a
brakes.
lot longer. Than,
Are you kidding me? We had the second most famous Groundhog Day in Pennsylvania, touting gambling all the time.
Yeah.
Yeah.
What?
Our Pennsylvania lottery
Oh yeah.
mascot is
Gus.
Pennsylvania Phil, right? No.
No,
Gus.
Gus, the second most. famous groundhog.
nobody. There's like 2 people listening right now that know what you're
Yeah.
talking about.
No, I
And
understand, but
and you know
Pennsylvania touts Groundhog Day so much that our lottery mascot is literally the second most famous groundhog.
Yeah, because he keeps on scratching. Scratch,
Yeah.
scratch.
He scratches the lottery tickets.
And
Anyway, so should we wrap this up?
Yeah,
I
yeah.
think we
Or
should-
should we at least try to reach out to the Pennsylvania Lottery Commission to see if we can get advertisements for this?
Yeah, send us some scratch offs.
Yeah, or something. You know.
if you're listening right now and you want us to get any more listener questions in, we'll do like a lightning round. I don't know. You got like literally 2 minutes, and then and then we'll sign off after this because we've been doing this for
We've
almost
hit
an hour
every
and a
question
half
now
now, but-
that have come in live.
well, I was just we got those 2 questions that came in, but anyone else out there just sitting there waiting? Speak now, forever hold your peace. I'm not going to drag it out much longer.
Yeah, let's call it.
Uh-oh.
Excellent answers.
Oh,
Okay.
yeah.
Okay. Love to destroy. Enjoyed our answers. Okay. Thank you. Thank you for the questions. That was
Thank
great.
you.
That was
Yes.
actually, it's fun playing Stump the Geologist.
And sorry for all of our worried looks or like, is that an actual question coming in?
Yeah, we need to put more plants in the audience. Let's throw softballs.
Yeah.
We'll get Maddie to do that next time. All right.
But Maddie,
All right,
thank you for listening. Everybody. Thank you. Everybody who's out
everyone,
there.
everyone, thanks for listening.
Yeah.
So I guess there was I want one really fast. This is literally like this will take 2 minutes, not even. There was a bright fireball over Tokyo explodes with the force of 165 tons of TNT. I'll have to put this one up on the YouTube not the YouTube. It's already up on YouTube. But there's a really cool video of you can see this fireball going across the sky of this meteor basically burning up in the atmosphere. So
Holy cow!
Yeah. So it happened like 2:30 a.m. in Japan local time, and I don't know, fun little thing. I've seen a couple of those in the sky. It's pretty wild when you see a meteor burning up in the atmosphere, because you're just like, number one, it catches you off guard, and then you're just like, what the hell was that thing? And you're like, that was pretty cool. Once you realize what it was, you're like, wow, that was pretty cool.
I've seen a few like driving like late at night on like a deserted highway, and you're like, what? I can see why people have UFO encounters late at night.
You've seen things entering the atmosphere while on a dark road?
Yep. I can't talk about it.
Being a bright road.
There's actually, if you're into stargazing.
This is for our Topaz members. Apparently, Jesse will reveal some of these UFO encounters.
Yeah, Jesse's blue book. If you're into stargazing, though, there's a visible comet passing in the northern hemisphere right now. Sort of tough. We have a full moon going on. Yesterday was a full moon, but it's going to be at its closest pass on the 22nd or 23rd. And if you have binoculars, you can see it.
Oh, neat.
Cool.
Or, something stronger, too. Got a telescope. You can see with a telescope.
Like scotch.
Yeah, there's some thought you could see if you know where you're looking, you can see with your naked eye. But I don't know. We live in light pollution central, so it's tough around here.
I got so actually for that, I remember for that story, I got a little prop for this one. I showed Jesse this right before we started recording, but if I talked about this on one of the previous episodes, this is the piece of the meteorite from the Chelyabinsk impact in Russia in 2013. So if you're looking on YouTube right now, I got a little piece right there. Supposedly, I don't know where this came from. I mean, I got this at a mineral show, whatever. I bought an asteroid I bought a meteorite, tiny little meteorite for a Christmas present. And I was talking to the lady, and she goes, "Oh, here, take this. This is from, this is the Chelyabinsk one from Russia in 2013. That was the one where you might have seen it on the news, where like stuff was, like you could see like the fireball streaking across the sky, and it actually, I guess the sonic boom from this thing busted up windows, and a couple people were hurt from this. But apparently in Russia, it's the thing to do to drive around with a camera in your windshield.
Yes.
I guess they have a lot of insurance fraud in Russia. I don't know. I think that's the reason why. It doesn't matter. But a lot of Russians.
So there's a lot of video evidence of this. Asteroid.
Yeah.
Also, you want to go down a YouTube rabbit hole.
Yeah.
Just the dash cam videos, you see like a tank go over the road.
And you might think like, oh, some windows got smashed. Like, this is like Siberia, Russia in the winter. Like, if your window gets smashed, it's a big deal. Like,
I mean, yeah,
you're going to be cold. So, yes, it was rather inconvenient for some people.
What shocked me about that was on those dash cam videos and just videos, you can find compilations, are the number of people. And this fireball, when it comes in, it's like the early morning, like dawn, so it's sort of dark, and it makes the whole sky like noon. It's bright when it burns up.
Yeah.
And then it explodes, and it's the explosion, the shock from the explosion that shattered windows. The number of people who were so unfazed by this thing in these videos, like there's a guy like in his car, just like it like flashes in front of him. He just keeps driving, like doesn't say anything.
Whatever.
People just having normal conversations. Like I'd be screaming and losing my mind.
Yeah. This is the end of days.
Yeah.
This is
Repent.
Yeah.
Oh man. All right, so let's wrap it up with that. I think covered
The end of
covered a
days.
fair amount of news stories right there. So thanks for everyone that was hanging out for
thanks.
the live stream.
Thanks for listening.
Thanks for the questions, and we saw some familiar faces, some I guess
Some new
usernames,
faces.
some new faces. That's always fun to see some of the new fans. So yeah, I love doing these things. This is a lot of fun. So
Cool.
all right, so let's wrap things up here. I can't talk. Be sure to check out the formatting formula. They help out with some of the costs for the show. So you can go to formattingformula.com or check out their YouTube videos, youtube.com/c/formattingformula. You can check us out on Facebook. You can check. Do you guys see that final question just came in from Maddie just now?
We'll get to it next episode.
What did it say?
All right. Sorry, Maddie. Well,
Oh,
What
man,
kind
you
of
were
tests
too late.
I was actually going to bring this up, but I'll cover it next time.
okay, we'll cover Maddie. We'll cover that one on next.
Maddie, this is
Sorry,
what's
Maddie. You
called-
had your chance, buddy.
This is what's called a cliffhanger, buddy. You're gonna have
Yeah.
to tune in next week.
The question was, what kind of test can you do to prove it's a meteorite? And we'll
If
get there.
only Maddie had our phone numbers and he could call us up to ask us.
Hey. He's setting us up so we can knock him out of the park. Thank you,
There
Maddie.
we go. Yeah.
Yes.
We'll sorry, Maddie. We got to wrap this up, but all right. What's it? Facebook.com. I feel like a jerk, but we gotta wrap this up. Facebook.com/ Geology Flannelcast. We're on comments. Funny. I'm losing my mind here.
Geo Flannelcast at Twitter.
At GeoFlannelcast on Twitter, geologyflannelcast.com. You can email some questions. We got some questions starting to pile up for another listener question episode. We'll probably do that sooner rather than later. So if you want to get it in relatively soon, you can go to geologyflannelcast.com and click on listener questions and submit a question that way. Or just email us at questions at geologyflannelcast.com. What else? Patreon. If you really enjoy the podcast and you'd like to help out, support the podcast a little bit. We have a bunch of different tiers set up on Patreon. And thank you to everyone. Thank you so much for everyone that has sponsored on Patreon and helped us out. We had a couple more coming this week. Thank you so much. You guys are awesome. We appreciate it so much. This is allowing us to get some equipment upgrades and kind of just make this podcast better.
And I did have a misquote last week. I said 45. I should have said 425. So
I think I just edited that out so nobody knows. And that was coming out next week, by the way. So that's
right.
What you said. So just disregard what Steve said.
I thought it was. I'm sorry. I thought it was 2 weeks ago. That's why I thought we were still on par here. But
we're all in COVID time. We don't know what's happening anymore.
The bottom line is we need more Patreon. So anything we can get, we appreciate. Yes, we really do appreciate it. So,
but thank you so much to everybody that has helped out. We appreciate it so much. We love doing this. We have a blast doing this, and you guys are just allowing us to keep on doing this. Man, these live streams are fun. I think we're gonna keep on doing these more often. But okay, I'm done jabbering along here. Thanks everyone. We love you guys. And you guys got anything else before I press this little end stream button?
No.
Well, I'm glad you asked, Chris. I'd like to start.
Okay. Thanks a lot. We love everyone.
Yes. No, I'm done.
All right, everybody. We love you guys, and we'll talk to you guys soon. Love you. Bye.
Bye. Thanks for stopping by.